In 1977, 2 spacecraft left Earth carrying a message intended for civilizations that may not even exist. Aboard each spacecraft was a golden record, a phonograph disc containing sounds and images from humanity. Music from Bach and Beethoven, greetings in 55 languages, photographs of human faces, landscapes, architecture, the sounds of rain, thunder, a mother's heartbeat. This record was designed to last billions of years, to survive long after humanity itself might be extinct, long after Earth might be consumed by the expanding sun. The spacecraft carrying these messages are called Voyager 1 and Voyager 2, and they are now the most distant human-made objects in existence. They have left the solar system. They are traveling through interstellar space, through the vast emptiness between stars. They will travel for tens of thousands of years before they come close to another star. And when they do, humanity may no longer exist to know about it. This is the story of 2 machines that became ambassadors to eternity, messengers to civilizations we will never meet, travelers to places no human will ever see. This is the story of Voyager. On September 5th, 1977, a Titan Centaur rocket lifted off from Cape Canaveral, Florida, carrying a spacecraft weighing 815 kilograms. 16 days earlier, a similar rocket had launched a nearly identical spacecraft. These were not ordinary missions. They were not designed merely to orbit Earth or visit a nearby planet. They were designed to leave the solar system entirely, to journey farther than any human artifact had ever traveled, to become the first emissaries of humanity to the cosmos beyond our sun's influence. The spacecraft were named Voyager 1 and Voyager 2, though paradoxically, Voyager 2 launched first. They were built to take advantage of a rare planetary alignment that occurs only once every 176 years, a configuration that would allow a single spacecraft to visit Jupiter, Saturn, Uranus, and Neptune in sequence, using the gravity of each planet to accelerate toward the next. This technique, called a gravity assist or gravitational slingshot, would enable the Voyagers to reach speeds and distances that would otherwise require far more fuel than any rocket could carry. But the Voyagers carried something unprecedented in the history of space exploration. Mounted on the side of each spacecraft, protected from cosmic radiation and micrometeorite impacts by a gold-plated aluminum cover, was a phonograph record, not a tape, not digital data, a physical record 12 inches in diameter made of gold-plated copper. Etched into its surface were analog audio waveforms and encoded images, 105th chart images, natural sounds from Earth, musical selections from different cultures and eras, spoken greetings in 55 languages. The Golden Record was the brainchild of Carl Sagan and a small committee of scientists, artists, and thinkers who faced an almost impossible task. How do you communicate the essence of humanity to beings who might discover the record millions or billions of years from now? How do you explain what Earth is, what humans are, what our civilization represents, when you cannot assume anything about the discoverer's biology, psychology, language, or technology? The record was a message in a bottle, cast into the cosmic ocean, with no certainty it would ever be found. The probability that the Voyagers would encounter another civilization is vanishingly small. The distances between stars are so vast, and the volume of space so immense, that the odds of either Voyager passing close enough to another star for detection are almost zero. Even if intelligent civilizations exist, even if they are common in the galaxy, the Voyagers are tiny needles in an incomprehensibly vast haystack. Yet the Golden Record was placed aboard anyway. Not because discovery was likely, but because it was possible. Not because we expected a reply, but because the act of sending the message was itself meaningful. The Golden Record represented humanity's aspiration to reach beyond itself, to communicate across the abyss of space and time, to assert that we existed, that we created beauty and meaning, that we reached outward toward the stars with curiosity and hope. The record begins with greetings, a voice in Sumerian, one of the oldest written languages, may all be well. A voice in English, hello from the children of planet Earth. A voice in Mandarin, in Hindi, in Arabic. Each greeting is brief, a few seconds, acknowledging the listener, welcoming them, offering goodwill from humanity to the cosmos. Then come the sounds of earth, waves breaking on a shore, wind rustling through leaves, thunder rumbling in the distance, footsteps, the song of a humpback whale, long, haunting, melancholic, the cry of a baby, laughter, a heartbeat. These are sounds that any technological civilization might not recognize, sounds that require context, sounds that speak of a living world, a world of biology and weather and oceans and life. Then comes the music. Bach's Brandenburg Concerto No. 2, a Javanese gamelan, a Navajo night chant, Beethoven's Fifth Symphony, Chuck Berry's Johnny B. Good, music from every inhabited continent, representing the diversity of human expression, the complexity of human emotion, the shared capacity for creating beauty through sound. And finally, encoded in the record are images. Photographs of Earth from space, a blue marble suspended in the blackness, continents and clouds visible against the oceans, images of human faces, young and old, from many ethnic backgrounds, images of landscapes, mountains, deserts, forests, rivers, images of cities, roads, buildings, structures, images of scientific diagrams, the solar system, the structure of DNA, mathematical definitions, a picture of a man and a woman standing together with a simple line drawing, showing human anatomy, scale, proportion. The golden record is, in every sense, a message of who we are, not as a species striving for conquest or domination, but as a species capable of wonder, creativity, curiosity, and love. It is humanity's hope that we are not alone, that somewhere in the galaxy, perhaps in another galaxy, civilizations exist who might one day find this record, decipher it, and know that we were here. Carl Sagan described the record this way: the spacecraft will be encountered, and the record played only if there are advanced spacefaring civilizations in interstellar space. But the launching of this bottle into the cosmic ocean says something very hopeful about life on this planet. The Voyagers were not designed to return. They carry no fuel to slow down, no means to turn around. They will continue travelling outward from the sun forever, or until they collide with something or are destroyed. Their golden records will endure, preserved in the vacuum of space for billions of years, long after the civilizations that created them have vanished. The Voyagers were designed to take advantage of a rare celestial alignment. In the late 1970s, the four giant outer planets, Jupiter, Saturn, Uranus, and Neptune, were positioned such that a spacecraft could visit all four in sequence, using gravity assist at each planet to reach the next. This configuration occurs only once every 176 years, and mission planners recognized it as a unique opportunity. A single spacecraft, launched at the right time along the right trajectory, could accomplish in 12 years what would otherwise require 4 separate missions over decades. Voyager 2 launched first on August 20th, 1977. Voyager 1 followed on September 5th, 1977, but along a faster trajectory that allowed it to overtake Voyager 2 and reach Jupiter first. The distinction in naming was based not on launch order, but on planned arrival times. Voyager 1 reached Jupiter in March 1979. The images it transmitted revolutionized our understanding of the giant planet. Jupiter was no longer an abstract fuzzy disk seen through telescopes. It was a world, a turbulent, dynamic, violent world of swirling clouds, immense storms, and crushing atmospheric pressures. The Great Red Spot, a storm larger than Earth that has raged for at least 350 years, was revealed in exquisite detail. Lightning flashed in the upper atmosphere. Auroras danced at the poles. The cloud bands, previously thought to be relatively static, were revealed to be constantly churning and evolving. But the most astonishing discoveries came not from Jupiter itself, but from its moons. Io, the innermost of the 4 large Galilean moons, was expected to be a dead, cratered world, like Earth's moon. Instead, Voyager 1 discovered active volcanoes erupting on Io's surface, the first active volcanoes ever observed beyond Earth. These eruptions were not powered by internal radioactive decay, as Earth's volcanoes are, but by tidal heating. Jupiter's immense gravity stretches and compresses Io as it orbits, generating friction and heat in Io's interior. This heat drives volcanic activity so intense that Io's entire surface is resurfaced every million years, an eye blink in geological time. Europa, another of Jupiter's moons, revealed a surface utterly unlike any other in the solar system. Europa is covered by a smooth shell of water ice, crisscrossed by long, dark cracks and ridges. Very few impact craters mar its surface, suggesting the surface is geologically young, constantly renewed by processes beneath the ice. Voyager's images hinted at what later missions would confirm. Beneath Europa's icy shell lies a global ocean of liquid water, kept warm by tidal heating, similar to Io's. This ocean may contain more water than all of Earth's oceans combined, and where there is liquid water, there is the potential for life. Voyager 1 then continued onward to Saturn, arriving in November 1980. Saturn's rings, visible from Earth as a simple band, were revealed to be extraordinarily complex. The rings are composed of countless particles of water ice, ranging in size from dust grains to house-sized boulders, all orbiting Saturn in a vast flat disk. Voyager discovered that the rings are divided into thousands of ringlets, separated by narrow gaps. Some gaps are maintained by small moons, orbiting within the rings, their gravity sweeping particles away. The rings are dynamic, constantly evolving, with waves and ripples propagating through them like ripples on a pond. Saturn's moon Titan, the second largest moon in the solar system, was a major target for Voyager 1. Titan is the only moon with a substantial atmosphere, denser than Earth's, composed mostly of nitrogen with traces of methane and other hydrocarbons. Voyager's cameras could not penetrate Titan's thick, hazy atmosphere, but the spacecraft's instruments revealed that Titan's surface temperature and pressure allow liquid methane to exist. Titan may have lakes or seas of liquid methane and ethane, making it the only other world in the solar system besides Earth with stable bodies of liquid on its surface. Voyager 1's encounter with Titan required a trajectory that sent the spacecraft out of the plane of the solar system, on a path that would not pass close to any other planet. This was the end of Voyager 1's planetary tour, though not the end of its mission. It would continue outward toward the edge of the solar system and beyond. Voyager 2 reached Jupiter in July 1979, 4 months after Voyager 1, and confirmed and extended the earlier discoveries. But Voyager 2's trajectory allowed it to continue the grand tour. In August 1981, it reached Saturn. Then in January 1986, it became the first and so far only spacecraft to visit Uranus. Uranus is a strange world. It orbits the Sun tipped on its side. Its axis of rotation is tilted 98 degrees relative to its orbital plane, meaning it essentially rolls along its orbit like a wheel, rather than spinning like a top. This extreme tilt may be the result of a massive collision early in the solar system's history. Voyager 2 discovered that Uranus has a faint ring system and at least 10 previously unknown moons. The planet itself appeared featureless in visible light, a pale blue-green sphere with almost no visible cloud features. This is because Uranus's atmosphere is extremely cold and composed mostly of hydrogen, helium, and methane, which absorbs red light and gives the planet its blue-green color. Finally, in August 1989, Voyager 2 reached Neptune, the outermost of the gas giants. Neptune is similar to Uranus in composition and size, but far more dynamic. Voyager 2 discovered enormous storms raging in Neptune's atmosphere, including the Great Dark Spot, a storm system comparable in size to Earth. Winds on Neptune reached speeds of over 2,000 kilometers per hour, the fastest winds measured anywhere in the solar system. How a planet so far from the Sun, receiving so little energy, could generate such powerful atmospheric dynamics remains a mystery. Neptune's largest moon, Triton, was another major discovery. Triton orbits Neptune in the opposite direction to the planet's rotation, suggesting it was captured by Neptune's gravity rather than forming in place. Voyager 2 discovered active geysers on Triton's surface, erupting nitrogen gas and dark material into space. Triton is one of the coldest objects in the solar system, with surface temperatures around -235 degrees Celsius, yet it is geologically active. The grand tour was complete. Voyager 2 had visited all 4 giant planets, transforming them from distant points of light into real, complex worlds. The data sent back by the Voyagers filled volumes. The images captured the public imagination. The discoveries reshaped our understanding of planetary science. But the Voyagers' mission was not over. They would continue travelling outward into regions of space no spacecraft had ever explored. On February 14, 1990, as Voyager 1 was approximately 6 billion kilometers from Earth, mission controllers commanded the spacecraft to turn its camera back toward the inner solar system and capture a series of images, a family portrait of the solar system. This was not part of the original mission plan. The camera would be turned off shortly afterward to conserve power, and the images were not scientifically valuable. But Carl Sagan had advocated for years that Voyager should turn around and photograph Earth from the outer solar system to capture an image that would show Earth's place in the cosmos. The image Voyager 1 returned is one of the most famous photographs ever taken. Earth appears as a tiny dot, less than a single pixel, suspended in a beam of scattered sunlight. The image is grainy, taken from an immense distance, barely showing Earth at all, yet it is profoundly moving. Carl Sagan later reflected on this image in a passage that has become iconic. Look again at that dot. That's here, that's home, that's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives. The aggregate of our joy and suffering, thousands of confident religions, ideologies, and economic doctrines, every hunter and forager, every hero and coward, every creator and destroyer of civilization, every king and peasant, every young couple in love, every mother and father, hopeful child, inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived there, on a mote of dust suspended in a sunbeam. The pale blue dot photograph became a symbol of Earth's fragility and humanity's smallness in the cosmic context. It was a reminder that all of human history, all our conflicts and triumphs, all our civilizations and empires occurred on a single tiny world, lost in the vastness of space. After taking the pale blue dot image, Voyager 1's camera was turned off permanently. The spacecraft continued its journey outward. Its destination was not another planet or moon, but the boundary of the solar system itself, the heliopause, the region where the sun's influence ends and interstellar space begins. The solar system is not merely the sun and the planets. The sun emits a continuous stream of charged particles, the solar wind, that flows outward in all directions, filling the solar system with a bubble of hot plasma. This bubble, called the heliosphere, extends far beyond the orbits of the planets. Within the heliosphere, the solar wind dominates. Beyond it lies the interstellar medium, the gas and dust that fills the space between stars. The boundary between the heliosphere and the interstellar medium is called the heliopause. This boundary is not sharp like the edge of a balloon, but gradual, a region where the pressure of the solar wind balances the pressure of the interstellar medium. The heliopause is not static. It fluctuates as the solar wind strengthens and weakens over the sun's 11-year activity cycle. It is also not spherical. The sun's motion through the interstellar medium compresses the heliosphere on one side and stretches it into a long tail on the other, like a comet. As the Voyagers travelled outward, their instruments detected changes in the surrounding environment. The density of solar wind particles decreased, the intensity of cosmic rays, high-energy particles from outside the solar system increased, the magnetic field shifted. These were signs that the spacecraft were approaching the heliopause. On August 25, 2012, Voyager 1 crossed the heliopause and entered interstellar space. It became the first human-made object to leave the solar system. The crossing was not dramatic. There was no sudden change, no clear moment when Voyager 1 passed through a boundary. The transition was gradual, marked by a decrease in solar wind particles and an increase in galactic cosmic rays. Mission scientists debated for months whether Voyager 1 had truly crossed the heliopause or was merely in a transition region. Eventually, after careful analysis of the data, they confirmed. Voyager 1 had left the heliosphere. Voyager 2 crossed the heliopause on November 5, 2018, becoming the second human-made object to enter interstellar space. Interestingly, Voyager 2 crossed at a different location and under different conditions than Voyager 1, providing valuable data on the structure and variability of the heliopause. But crossing the heliopause does not mean the Voyagers have left the Sun's gravitational influence. The Sun's gravity extends far beyond the heliopause, binding distant comets in the Oort cloud, a vast spherical shell of icy bodies surrounding the solar system. The Oort cloud extends perhaps 1 light-year from the Sun. The Voyagers will not leave the Oort cloud for tens of thousands of years. Still, the Voyagers are now in interstellar space. They are travelling through the medium between stars. They are no longer within the Sun's protective bubble. They are exposed to the interstellar environment, cosmic rays, interstellar gas, magnetic fields, measurements that cannot be made from Earth or even from spacecraft within the heliosphere. The Voyagers continue to send data back to Earth. Their instruments measure the density and composition of the interstellar medium, the strength and direction of magnetic fields, the intensity of cosmic rays. This data is transmitted across billions of kilometers by radio signals traveling at the speed of light. When Voyager 1 transmits, the signal takes over 22 hours to reach Earth. When we send a command to Voyager 1, the command takes 22 hours to arrive, and the response takes another 22 hours to return. A simple exchange takes nearly 2 days. The Voyagers are powered by radioisotope thermoelectric generators, RTGs. These devices convert the heat from radioactive decay of plutonium-238 into electricity. When the Voyagers launched, the RTGs produced approximately 470 watts of power. Over time, as the plutonium decays, the power output decreases. By 2025, the Voyagers generate only about 200 watts, enough to power a few light bulbs, barely enough to keep the instruments running and the transmitters operating. Mission engineers have been shutting down instruments one by one to conserve power. The cameras were turned off decades ago. Heaters that keep the instruments warm have been turned off. Non-essential systems have been shut down. The Voyagers are running on minimal power, operating on the edge of survival, but they continue to function. By the early 2030s, the RTGs will no longer produce enough power to operate any instruments. The Voyagers will fall silent. They will continue travelling outward, coasting through space, no longer sending data, no longer responding to commands. They will become inert artifacts drifting through the galaxy, carrying their golden records as silent testimony to the civilization that built them. Interstellar space is not empty. The interstellar medium, the gas and dust between stars, has a density of about 1 atom per cubic centimetre. This is an extraordinarily good vacuum by terrestrial standards, far better than any vacuum we can create in a laboratory. Yet over the vast distances of interstellar space, this thin medium accumulates. It contains hydrogen, helium, traces of heavier elements, dust grains, organic molecules, even complex carbon-based compounds. The Voyagers are measuring this medium directly for the first time. They have detected fluctuations in density, suggesting the interstellar medium is not uniform, but structured. There are regions of higher density and regions of lower density. There are magnetic fields threading through the medium, shaping its structure and influencing the motion of charged particles. There are cosmic rays, high-energy particles, mostly protons, accelerated to nearly the speed of light by supernova explosions and other violent cosmic events. Cosmic rays constantly bombard the Voyagers. The spacecraft were not designed to withstand decades of cosmic ray exposure. Over time, cosmic rays degrade the electronics, causing bit flips in memory, damaging circuits, shortening the lifespan of components. The fact that the Voyagers continue to function after more than 4 decades is a testament to the robustness of their design and the skill of the engineers who built them. But the interstellar medium is only part of the environment the Voyagers are travelling through. They are also travelling through the gravitational field of the Milky Way galaxy. The galaxy is a vast spiral of stars, gas, and dark matter, containing between 200 billion and 400 billion stars. Our Sun is located in a minor spiral arm called the Orion Arm, about 26,000 light-years from the galactic centre. The Sun orbits the galactic centre at approximately 220 kilometers per second, completing one orbit every 225 million years, a period called a galactic year. The Voyagers are travelling relative to the Sun, but the Sun itself is moving through the galaxy. The Voyagers' trajectories relative to the galaxy are complex, influenced by the Sun's motion, the motion of nearby stars, and the overall rotation of the galaxy. Voyager 1 is heading roughly toward the constellation Ophiuchus. Voyager 2 is heading roughly toward the constellation Telescopium. Neither is aimed at any particular star, but over tens of thousands of years they will pass near other stars by chance. In approximately 40,000 years, Voyager 1 will pass within about 1.6 light-years of the star AC Plumsen 79 3888, a red dwarf in the constellation Camelopardalis. This is not a close approach by interstellar standards. 1.6 light-years is still an immense distance, roughly 100,000 times the distance from Earth to the Sun. But it is the closest Voyager 1 will come to another star for hundreds of thousands of years. In approximately 296,000 years, Voyager 2 will pass within about 4.3 light-years of Sirius, the brightest star in Earth's night sky. Again, this is not a close approach. Sirius is a binary star system, consisting of Sirius A, a bright main sequence star, and Sirius B, a white dwarf. Voyager 2 will pass through the outer regions of the Sirius system, but it will not be captured by the star's gravity. It will continue onward. Over millions of years, the Voyagers will pass near many stars, always at great distances. They will drift through the galaxy, following complex, unpredictable paths influenced by the gravitational fields of stars they pass, by the overall gravitational potential of the galaxy, by encounters with giant molecular clouds, vast regions of dense gas where stars are born. Their paths will be chaotic in the mathematical sense, meaning that tiny changes in initial conditions lead to vastly different outcomes over long timescales. We cannot predict whether Voyagers will be 1 billion years from now with any precision, but we can say this: the Voyagers will continue travelling outward from the solar system indefinitely. They will not return. They will not fall into the Sun or be captured by another star in the foreseeable future. They will drift through the galaxy for billions of years, long after the Sun has become a white dwarf, long after Earth has been destroyed, long after humanity itself has vanished or evolved into something unrecognizable. The golden records aboard the Voyagers are the most enduring artifacts humanity has ever created. On Earth, all our monuments, all our buildings, all our art and literature and science will eventually be destroyed by erosion, by tectonic activity, by the Sun's expansion in 5 billion years. Even if humanity survives on other worlds, Earth itself will not endure, but the golden records will survive. In the vacuum of space, they are shielded from the processes that destroy things on Earth. They will be preserved for billions of years, perhaps for trillions of years, perhaps until the end of the universe itself. The golden record is not merely a collection of sounds and images. It is a carefully designed communication system, intended to be decipherable by an intelligent civilization that discovers it. The cover of the record includes a diagram showing how to play it, a stylus, a turntable, the correct rotational speed. The diagram assumes nothing about the technology of the discoverer except that they are capable of spaceflight, that they understand basic physics, and that they can interpret visual diagrams. The record includes instructions for decoding the images. The images are not stored as photographs, but as analog waveforms, similar to television signals. A diagram on the cover explains how to reconstruct the images from the audio signal. The diagram uses hydrogen, the most common element in the universe, as a reference. The transition between the two lowest energy states of hydrogen emits radiation at a specific wavelength, a universal constant that any technological civilization would recognize. This wavelength is used as a unit of measurement in the diagrams, allowing the discoverer to decode time intervals, distances, and rotational speeds. The record's contents were selected by a committee led by Carl Sagan, including scientists, artists, writers, and musicians. The selection process was constrained by the record's capacity. Only 90 minutes of audio or equivalent data. Every second had to be used carefully. Every image, every sound, every greeting had to be chosen to maximize the information conveyed while minimizing redundancy. The greetings in 55 languages were meant to show the diversity of human cultures and languages. The natural sounds, surf, wind, thunder, birdsong, whale song, were meant to convey the nature of Earth as a living world with weather, oceans, and biology. The music was selected to represent the breadth of human artistic expression, from ancient folk traditions to contemporary rock and roll. The images were perhaps the most challenging. How do you explain what a human is, what Earth is, what our civilization represents, using only static images? The committee selected images showing human anatomy, reproduction, development, images showing landscapes, mountains, forests, oceans, deserts, images showing cities, roads, bridges, buildings, images showing technology, vehicles, aircraft, spacecraft, images showing scientific knowledge, the solar system, the structure of DNA, mathematical concepts. One image shows a man and a woman standing together, naked, with a line drawing showing their proportions. This image was controversial. Some argued that nudity might be offensive or misunderstood by an alien civilization. Others argued that showing humans in clothing would be confusing. The aliens would not know what parts were biological and what parts were artificial. The decision was made to show humans as they are, biologically, without cultural adornments. Another image shows a supermarket, aisles filled with packaged food. This image was meant to convey the abundance and complexity of human civilization, the fact that food is produced and distributed on a massive scale, that humans have developed complex economic systems, yet to an alien observer the image might be incomprehensible. What are these colourful packages? Why are they arranged in rows? What is the purpose of this space? Without context, the image might convey nothing. This is the fundamental challenge of interstellar communication. How do you communicate with beings who share no common ground, no common experience, no common frame of reference? Every image, every sound, every symbol on the golden record assumes something about the discoverer. It assumes they have vision or some equivalent sense that allows them to perceive images. It assumes they understand the concept of time and sequence. It assumes they recognize mathematical and physical constants. It assumes they have some concept of biology, of life, of planets and stars. Yet these assumptions may be wrong. An intelligent civilization might be so alien, so different from us, that our attempts at communication are meaningless. They might perceive the universe in ways we cannot imagine, using senses we do not possess, organizing reality through concepts we cannot conceive. The golden record might be to them what an ancient cave painting is to us, interesting perhaps, as an artifact, but incomprehensible as communication. Carl Sagan was aware of these challenges. He understood that the golden record was unlikely ever to be found, and if found, might never be understood. Yet he argued that the record's value was not in its probable discovery, but in its existence. The act of creating it, the process of deciding what to include, the reflection on what humanity is and what we value. These were the true purposes of the golden record. Sagan wrote, "The spacecraft will be encountered and the record played only if there are advanced spacefaring civilizations in interstellar space. But the launching of this bottle into the cosmic ocean says something very hopeful about life on this planet." The golden record is a statement of hope, hope that we are not alone, hope that intelligence and curiosity exist elsewhere, hope that we are part of something larger than ourselves. The Voyagers are now the most distant human-made objects in existence. They are farther from home than any artifact we have ever created. They have travelled farther than any explorer, any ship, any probe. They represent humanity's farthest reach into the cosmos, and they are travelling ever farther into regions of space we will never visit in our lifetimes, perhaps never visit at all. There is something profoundly lonely about the Voyagers. They are alone in the interstellar void, surrounded by emptiness. The nearest stars are light years away. The nearest spacecraft, Pioneer 10 and Pioneer 11, which preceded the Voyagers and are also travelling outward, are billions of kilometres distant. The Voyagers will never encounter each other again. They will never return to Earth. They are exiles, wanderers, eternal travellers with no destination and no hope of homecoming. Yet, in another sense, the Voyagers are not alone. They carry with them the hopes and dreams of humanity. They carry the golden record, a message from Earth, a testament to our existence. They carry the accumulated knowledge of a civilization that looked up at the stars and decided to reach out, to explore, to communicate. They are ambassadors in the truest sense, representatives of our species, travelling to places we cannot go, carrying our message to beings we may never meet. The Voyagers have become symbols. They represent the human drive to explore, to push beyond known boundaries, to seek knowledge and understanding. They represent the hope that we are not alone, that intelligence exists elsewhere in the universe, that we might one day make contact. They represent the fragility and preciousness of life. Carl Sagan's pale blue dot, a reminder that Earth is a tiny, vulnerable world in a vast and indifferent cosmos. The Voyagers have also become objects of cultural significance. They appear in films, television shows, novels, art. They are invoked in discussions about space exploration, about humanity's future, about our place in the universe. They have inspired generations of scientists, engineers, and dreamers. They have become part of our collective mythology, symbols of the age of exploration, of the moment when humanity first reached beyond the solar system. Yet the Voyagers are also reminders of our limitations. They are travelling at approximately 17 kilometers per second, fast by human standards, but incredibly slow on cosmic scales. At this speed, it would take Voyager 1 over 73,000 years to travel 1 light year. The nearest star, Proxima Centauri, is 4.24 light years away. It would take Voyager 1 over 300,000 years to reach Proxima Centauri if it were headed in that direction, which it is not. The distances between stars are almost incomprehensibly vast. The galaxy contains hundreds of billions of stars, yet the average distance between stars is measured in light years. Distances that would require tens of thousands or hundreds of thousands of years to traverse even at speeds far beyond what we can currently achieve. Interstellar travel is not merely difficult, it may be effectively impossible for biological beings. The timescales are too long, the distances too vast, the energies required too enormous. The Voyagers will drift through the galaxy for billions of years, but they will almost certainly never encounter another civilization. The odds are simply too small. Space is too vast, and civilizations, if they exist, are too rare and too scattered. The Voyagers are messages in bottles thrown into an ocean so immense that the bottles will almost certainly drift forever, never found, never opened, never read. Yet the attempt matters. The fact that we sent the message, that we tried to reach out, that we acknowledged the possibility of other intelligences and attempted to communicate with them, this is meaningful in itself. It speaks to something essential in human nature: curiosity, hope, the desire to connect, the refusal to accept that we are alone. The Voyagers are dying, their power is fading. The radioisotope thermoelectric generators that have kept them alive for over 4 decades are gradually running out of fuel. Each year, the power output decreases. Each year, mission engineers must make difficult decisions about which instruments to shut down, which systems to conserve, how to extend the mission for as long as possible. By the early 2030s, the RTGs will no longer produce enough power to operate any instruments. The Voyagers will fall silent, they will stop transmitting data, they will stop responding to commands. The radio link that has connected them to Earth for over 50 years will be severed. The Voyagers will continue travelling outward, but humanity will no longer hear from them. This will be a strange and melancholy moment. For the first time since their launch, the Voyagers will be truly alone, cut off from all contact, drifting through space in silence. The engineers and scientists who have worked on the Voyager mission for decades, some for their entire careers, will lose connection with the spacecraft they have guided and cared for. The mission will officially end, though the Voyagers themselves will continue their journey indefinitely. Mission engineers have already begun preparing for this moment. They have been shutting down instruments one by one to conserve power, prioritizing the instruments that provide the most valuable data about the interstellar environment. The Plasma Science instrument, which measures charged particles, was shut down on Voyager 1 in 2007 due to budgetary constraints. The Planetary Radio Astronomy instrument was shut down in 2008. The Cosmic Ray Detector, the Magnetometer, the Plasma Wave instrument. These continue to operate, but they too will eventually be shut down. There are proposals to extend the mission slightly longer by shutting down the heaters that keep the instruments warm. The instruments were designed to operate at specific temperatures, and allowing them to freeze could damage them. But at this point, the mission is so close to its end that the risk may be acceptable. A few more months or years of data might be gained by allowing the instruments to freeze, and the data would be valuable. The interstellar medium is not well understood, and every additional measurement helps. When the Voyagers fall silent, they will not be forgotten. Their legacy is secure. They have provided some of the most important data in the history of planetary science. They have revealed the outer planets as dynamic, complex worlds. They have entered interstellar space and begun measuring the environment between stars. They have inspired generations. They have shown what is possible when humanity commits to exploration, when we reach beyond the familiar, when we venture into the unknown. And the Voyagers will continue to exist. Long after they fall silent, they will drift through the galaxy, carrying their golden records. They will pass near other stars, perhaps close enough for those star systems' inhabitants, if any exist, to detect them. They will survive for billions of years, perhaps for trillions of years, outlasting humanity itself. In a sense, the Voyagers are immortal. They are artifacts that will endure longer than anything else we have created. They are time capsules, preserving a snapshot of humanity in the late 20th century, a moment when we were just beginning to explore the solar system, just beginning to understand our place in the cosmos. They are messages to the future, to civilizations that may exist billions of years from now, long after the sun has died and Earth has been destroyed. Imagine, billions of years from now, a starship traveling through the galaxy. The civilization that built this starship is ancient beyond measure. They have existed for millions or tens of millions of years. They have explored their local star systems. They have perhaps encountered other civilizations. They have technologies we cannot imagine. They have long since spread beyond their home world, colonizing other planets, building habitats in space, perhaps even altering the structure of stars and planets to suit their needs. This starship is on a long journey, traveling between star systems, conducting surveys, exploring, perhaps simply wandering. Its sensors detect an object drifting through space. The object is small, only a few meters across, moving at a modest velocity, emitting no signals, generating no power. It appears to be debris, a fragment of some ancient artifact. But as the starship approaches, its sensors reveal something unexpected. The object is artificial. It is a spacecraft, ancient and inert, but clearly the product of a technological civilization. Its surface is covered in strange markings, symbols that might be language or diagrams or decoration. There is a disc attached to the side, protected by a metal cover. The cover has markings as well, diagrams, symbols, perhaps instructions. The civilization retrieves the spacecraft. They bring it aboard their starship or transport it to a facility. They study it carefully, They analyze the materials: copper, aluminum, gold, titanium, traces of plutonium-238. They examine the structure: solar panels, antennae, instruments, a computer, memory storage. They recognize it as a probe, a machine designed to travel through space, to collect data, to transmit information. They find the disk, they remove the protective cover, they examine the diagrams etched onto the cover. These diagrams are mathematical, using simple symbols and relationships. The civilization's mathematicians study the diagrams and realize this is a communication system. The disk is a record, a phonograph, designed to store information as analog waveforms. The diagrams explain how to play the record, how to decode the images, how to interpret the sounds. They build a device to play the record, they extract the audio waveforms, decode the images, process the data. They hear the greetings in 55 languages, though they understand none of them. They hear the natural sounds: waves, wind, thunder, whale song. They hear the music: Bach, Beethoven, Chuck Berry, Navajo chants, Javanese gamelan. They see the images: human faces, landscapes, cities, scientific diagrams. What do they make of it? How do they interpret this strange message from a long-dead civilization? Do they recognize the humans in the images as intelligent beings? Or do they see us as primitive creatures, barely conscious, hardly worth notice? Do they understand the music as art, as expression of emotion and beauty? Or do they interpret it as random noise, meaningless patterns of sound? Do they grasp the significance of the DNA diagram, the representation of life's molecular foundation? Or is it incomprehensible to them, alien biology so different from their own that the concept of DNA is meaningless? Perhaps they do understand. Perhaps their civilization has encountered other species, other forms of intelligence, and they have learned to interpret alien communication systems. They study the golden record carefully. They analyze the patterns in the images, the structure of the sounds, the mathematical constants used in the diagrams. They piece together a picture of the civilization that sent this message. They learn that we are biological beings, carbon-based, evolved on a planet with oceans and an atmosphere. They learn that we have vision, that we see the world in certain wavelengths of light. They learn that we hear sound, that we communicate through vibrations in air. They learn that we live in communities, that we build structures, that we create art and music. They learn that we are curious, that we reached out into space, that we attempted to communicate with other intelligences, even though we did not know if any existed. And perhaps in learning these things, they feel something. Recognition perhaps, or sympathy, or sadness. They recognize us as kindred spirits, beings like themselves, seeking to understand the universe, reaching out to connect, hoping they are not alone. They see in the golden record not merely information, but emotion. Hope, loneliness, curiosity, the desire for connection. Or perhaps they feel nothing. Perhaps their civilization is so alien, so far removed from anything resembling human experience, that our message is incomprehensible to them. They recognize the Voyagers as artifacts, as probes built by an intelligent species, but the golden record's contents are noise, patterns without meaning. They catalogue the discovery, record the data, and move on. Or perhaps no one ever finds the Voyagers. Perhaps they drift through the galaxy for billions of years, passing near stars, but never close enough to be detected. Perhaps they continue until the end of the universe itself, eternal wanderers in a cosmos that has forgotten them. The Voyagers were products of their time, the 1970s, an era of optimism about space exploration, when humans had walked on the moon, and the future seemed to promise continued expansion into the solar system and beyond. The Voyagers represented the pinnacle of that era, the farthest reach of humanity's exploratory impulse. Yet in the decades since the Voyagers launched, humanity's relationship with space exploration has changed. The Apollo program ended, the Space Shuttle program ended. The focus shifted from exploration to practicality. Satellites for communication, GPS, Earth observation, robotic probes continued to explore the solar system, Mars rovers, orbiter missions to Jupiter and Saturn, landers on comets and asteroids. but none ventured as far as the Voyagers. The Voyagers may be the last spacecraft to leave the solar system for many decades, perhaps for centuries. There are no current plans for missions beyond the heliopause. The nearest stars are so far away, and the travel time so long, that interstellar missions seem effectively impossible with current technology. Yet there are proposals. The Breakthrough Starshot Initiative, backed by physicist Stephen Hawking and entrepreneur Yuri Milner, proposes using powerful lasers to accelerate tiny spacecraft, each weighing only a few grams, to a significant fraction of the speed of light. These spacecraft would be equipped with light sails, vast reflective sheets that capture the momentum of laser light. By focusing an enormous laser on the sail for a few minutes, the spacecraft could be accelerated to perhaps 20% of the speed of light, fast enough to reach Proxima Centauri in about 20 years. Such spacecraft could not carry golden records or complex instruments. They would be miniature probes, carrying only cameras and transmitters designed to fly past the target star at high speed, capture images, and transmit them back to Earth. The transmission would take over 4 years to reach Earth, traveling at the speed of light. But if successful, such a mission would represent humanity's first visit to another star system. There are also proposals for interstellar probes using nuclear propulsion, antimatter engines, or even more exotic technologies. None are currently feasible, but they represent the dreams of future exploration, the hope that one day, perhaps in the next century or the century after that, humanity will build starships capable of crossing interstellar distances within a human lifetime. Yet even if such missions become possible, the Voyagers will remain unique. They were the first, they were the pioneers. They ventured into the unknown with primitive technology, with no certainty of success, with no predecessors to learn from. They succeeded beyond all expectations, functioning for over 4 decades, far longer than their designed lifespan. They explored 4 planets in detail and entered interstellar space. They carry the golden record, a message intended for civilizations that may exist billions of years from now. The Voyagers are humanity's first ambassadors to the galaxy. They may be our only ambassadors for a very long time. They represent a moment in human history when we reached beyond ourselves, when we decided that exploring the cosmos was worth the effort and the cost, when we looked up at the stars and decided to reach out. The Voyagers were designed to explore planets, to gather scientific data, to push the boundaries of human knowledge, and they succeeded magnificently. They transformed our understanding of the outer solar system. They revealed Jupiter's volcanic moon Io and Europa's subsurface ocean. They showed Saturn's rings in exquisite detail and discovered moons and atmospheric phenomena on Uranus and Neptune. They entered interstellar space and began measuring the environment between stars. The scientific legacy of the Voyagers is immense and enduring, but the Voyagers' significance extends beyond science. They represent something deeper about human nature: curiosity, hope, the desire to reach beyond the familiar, the refusal to accept that we are confined to one small world. The Voyagers embody the idea that exploration is worthwhile for its own sake, that knowledge and understanding are valuable even if they do not bring immediate practical benefits. The Golden Record is perhaps the most profound expression of this. It was not necessary for the mission's scientific goals. It added weight and complexity. It required time and effort to create. Yet it was included because Carl Sagan and others believed it was important to send a message to assert that humanity exists, that we are curious and creative, that we hope we are not alone. The Golden Record has become a symbol of hope and connection. It represents the idea that despite our differences, our many languages, cultures, religions, ideologies, we are all part of a single species, inhabitants of a single world, united by our shared curiosity about the cosmos. The record includes greetings in 55 languages, music from cultures around the world, images of diverse landscapes and peoples. It is a message from all of humanity, not from any single nation or culture. In creating the record, the committee faced difficult questions. What is essential about humanity? What should we communicate to alien intelligences? What do we want to be remembered for? These are not merely practical questions. They are philosophical and existential questions. They force us to reflect on who we are, what we value, what we want our legacy to be. The record's contents reveal something about how we see ourselves. We chose to include beauty, music, art, images of nature. We chose to include knowledge, scientific diagrams, mathematical constants, representations of our place in the solar system. We chose to include diversity, languages, cultures, faces from around the world. We did not include images of war, violence, suffering, conflict. We chose to present ourselves not as we are in all our complexity, but as we hope to be seen. Peaceful, curious, creative, united. This has been criticised by some as dishonest, as presenting a sanitized version of humanity that ignores our darker aspects. But others argue that the golden record is aspirational, a statement of what we hope to become, rather than what we are. It is a message about our better angels, about the potential we see in ourselves, about the civilization we might build if we overcome our conflicts and divisions. The Voyagers also remind us of our fragility and our mortality. They are drifting away from us, beyond our reach, beyond our ability to repair or recover. One day they will fall silent, and we will never hear from them again. They will continue their journey alone, carrying our message into a future we cannot imagine, to places we will never see. They are reminders that everything we create is temporary, that all our achievements will one day be forgotten, that even the earth itself will not last forever. Yet in this impermanence, there is also beauty. The Voyagers are wanderers, eternal travellers, carrying our message across the galaxy. They are statements of defiance against the vastness and indifference of the cosmos. They assert that we were here, that we mattered, that we reached out and tried to connect. They are monuments not to power or conquest, but to curiosity and hope. Carl Sagan once wrote, "For small creatures such as we, the vastness is bearable only through love." The Voyagers embody this idea. They are expressions of love, love for knowledge, love for exploration, love for the possibility of connection, love for the cosmos itself. They are small, fragile machines drifting through infinite space, yet they carry within them something profound and enduring, the human spirit. The Voyagers will outlast us. Long after humanity has gone extinct or evolved beyond recognition, the Voyagers will continue their journey. They will drift through the galaxy for billions of years, perhaps encountering other civilizations, perhaps drifting forever in silence. They are our legacy, our gift to the future, our message to the cosmos. And perhaps one day, billions of years from now, in a galaxy vastly changed from what we know, an intelligence will find one of the Voyagers. They will decode the golden record. They will see the images, hear the sounds, read the greetings. They will learn that once, on a small world, orbiting an ordinary star, a species existed that looked up at the stars and decided to reach out. They will know that we were here, and in that moment of discovery, the Voyagers will have fulfilled their purpose. They will have connected us to something larger than ourselves, something that transcends time and space and mortality. They will have proven that reaching out, trying to communicate, hoping for connection, that these are worthwhile, even in the face of vast cosmic indifference, even knowing that we may never receive a reply. The Voyagers are humanity's message to eternity. They are proof that we existed, that we wondered, that we hoped, and that message will endure long after everything else we have created has turned to dust.